And we're live. Hello, everybody. Welcome to this month's Encompass training. It's actually last month's because I had some technical difficulties, but we're going to go ahead and do it today. So Reggie is otherwise busy, so I'm going to go ahead and do this one myself with you guys. So this time we're going to go into we're going to go somewhere we don't want to go yet, okay? We're going to go into heating maintenance. So we have a whole class at the end of this month about heating maintenance, but I really wanted to touch on one specific subject that I know you guys are going to see a lot of. And you're going to see it earlier this year because we have winter coming much, much sooner than any of us expected. So like right now in Maine, it's like 55 degrees outside and it got down to like 39 last night. So we're going to go ahead and touch on furnace maintenance because I know that you guys are going to see this a lot and I know you're going to see it before the end of the month. So I want to make sure that you guys have the tools that you need to be able to do a sufficient job when you are maintaining or tuning up a furnace. So in my presentation, I have some screens that you're going to want to pause and screenshot. They're helpful tips and tricks and checklists for when you're doing a maintenance for furnace. Sorry, guys, my kitty wants to be in on the show. So I'm going to go ahead and present. I will keep an eye on the comments. If you guys have any questions, please feel free to ask them. I will go through all of the comments after the presentation. I don't like to sit in a slideshow the entire time because this should be interactive. And what Reggie wants for you guys is for you to be able to have a space, and he wants to provide that space for you guys to be able to ask questions and get those questions answered. Maybe it's something that you saw in the last couple of months that you really aren't sure about. Maybe it is a troubleshooting issue that you've been going through and you're not really sure how to handle it. Maybe it's something completely unrelated and it's related to parts, and it's a great question for Reggie, which I will send to him after. So make sure you ask those questions, you guys. We're here to answer them for sure. So without further ado, I am going to go ahead and present. Ooh. There's so many choices. Hold on, guys. All right, we are going to go ahead and share. So this is a slideshow that I made specifically for you guys. This slideshow is for people who have never seen a furnace before, right? All the way up to people who work on these every single day. I'm hoping it's not going to be boring. I hate slideshows, you guys. I've told you that before. But this is just the easiest way for me to teach you guys anything from so far away. And, virtual training is the future. And that's what Encompass wants for you guys. So without further ado, we will go ahead and start. So let me just see if I can maximize this anymore. It's supposed to be in full slideshow view, but it's not. But all right, we'll go over it as we go anyway. Sorry, you guys, if that looks small on your screens. I will try to make sure that I touch on everything that's on the slides, so you don't necessarily have to have them. But again, when I tell you guys to pause and screenshot, even if it seems silly, do it, because I promise you that there's going to be a situation where you need these tools in your tool belt. So here we go. Furnace maintenance and troubleshooting, a SkillCat presentation for Encompass by Jennifer Manzo. That's me. So what is a furnace and what are the major components of a furnace? So last time we talked about mini splits. We talked about heat pumps before. So that's where we are leaning as a society, and that's why we talk about them so much. But we can talk until we're blue in the face. It's not going to stop our homeowners from having gas and oil furnaces, right? So the first thing that I need to say is never, ever touch a gas or oil system unless you are licensed or unless you're with a licensed technician. So that out of the way, we have a beautiful installation job. I don't know who did this. This wasn't one of mine, but I found it on Google and loved it. So I wanted to share it with you. The first thing about installation is that this is how it should look. There should be plenty of space for everything you're putting in, even if the space doesn't allow it. If you're scrunching stuff in and you're not able to pull off panels and service it later, you're going to have a problem. So we will get into the installation side in a couple of months, but I really want to touch on service and maintenance today. So we have a heat exchanger, a burner, a flue, a blower, ductwork, and ventilation pipes. These pipes are air intake and exhaust, and then you have the ductwork that goes obviously through the house. So Everything else is in this tiny little box. And that's the thing about furnaces, is that sometimes they can be hard to service just because everything is in such a small little place. But I'm going to show you all of that. So here's the inside. So what does a furnace do? A furnace pulls air from the home through the ductwork, out the return, back to the furnace. It pulls it through the air filter, which is a very important part of the system. It's not one of the major components, but it is definitely a necessary one. So it pulls through the air filter. And as you can see, guys, after the air filter, this is where we get into the important stuff. So what happens when you don't have an air filter or you don't have the right air filter? All of the debris that's coming through the return is sucking right into your blower wheel, into your burners, into your heat exchanger. You have all these things happening that just delay the run of your system. They make you run so inefficiently that it's just, you're going to have problems either way. And things break. When things get dirty, they break. These components are situated behind the air filter because they're not supposed to get dirty because they will break. So directly after the air filter, we have the blower motor. You guys have seen plenty of bad ones. Those of you who work on furnaces, those of you who don't, it's a great place to start when troubleshooting. Blower motors go bad all the time, and they're a super crucial part of our system. So the blower motor is what makes sure that we have proper static pressure and make sure that we have correct airflow across any coils. If you have a dual fuel system, you'll have a AC coil on top here, and this filter protects all of that. The blower is going to go from this compartment and blow the air across the burners. The burners are going to light with this gas valve right here. They're going to light, whether it's a hot surface igniter or a flame sensor, you're going to have either spark or heat that's going to cause that gas to burn. And when the gas does burn, it goes through these little tubes that are called venturis. Well, through the orifice and then through the venturis, you're going to have fire. And then the fire is going to heat the air. The air then comes up and heats the heat exchanger. That heat exchanger is what gives us the supply air heat into our home. So it's going to come past these heat exchangers. The heat exchangers are going to stay really hot. And so the important thing to note here is that when we are using burners in a situation like this, we are not heating the air with fire. We're heating the heat exchanger, which then heats the air with the heat that it is transferring to that air, to that cooler air. Heat always transfers to cold. So when you've got a hot heat exchanger and cold air coming in from the return, it's going to heat that air and it's going to blow that air back through the supply into our ductwork and into our home. That is the major working of this system. So if you were confused about how furnaces work before, take a screenshot of this page. This will help you know kind of sequence of events. And sequence of events, sequence of operations is the most important thing we can know when we ever have to troubleshoot a system of any kind. So now that we know where the components are situated, we know what direction our flow goes, there are some things that could definitely go wrong, right? So I want to kind of go over those things just so you guys know what to look for. When we're not technically HVAC technicians, it can be hard to know where to start. And so what we need to give you, the best tool I can give you in your tool belt is knowing where to start. I do own a tech support line. I can't tell you guys how many times I have technicians calling me just because they don't know what to check first. So we're going to go over that. And if you guys want to screenshot this page, absolutely go for it. I fully recommend it so that you don't forget. Again, you can take notes, whatever you want, but make sure that you are storing this information away somewhere for heating season. So probably the most common one I see in the winter is we get a 90% furnace, which makes a lot more condensate than an 80%. When that happens, we're not putting them in the attic because of it, and we should be. So at my company, if we're going to put a 90% furnace in, we're not going to do it in the attic. And if we are going to do it in the attic, we're going to add a condensate pump, which is going to keep that water moving all the time. We're going to put heat tape around it. We're going to make sure everything that we can do to stop it from freezing has been done long before winter ever hits. What we recommend is a mechanical room, a closet, a basement. If you can put your furnace somewhere else, that is always the best bet if it's a 90+%. And that's because our attics aren't typically conditioned. They get cold and we have this kind of stagnant water flow through our condensate line all the time. So typically where it freezes, like in this picture, is where it meets the house. So wherever that condensate line comes out of the house to drain, that's where your first clog is going to be. It's going to freeze because of the outside air. The water is colder than the air freezes the water, and then we have a backup of ice all the way back to our unit. And I have seen this cause more problems than I can count. So the number one thing to remember is if you get a call out for no heat and you notice that your drain line is frozen, check to see if it's a 90%. If it is, you're going to want to put a condensate pump. You're going to want to thaw it out with a torch, or if you have to cut the pipe out, sometimes you have to cut the pipe out and start over. But you're going to fix the problem, the clog itself, and then you're going to prevent it from happening again. That is the best advice I can give you. Never, ever just come and unclog a drain that's frozen and leave it. You always have to do something that is going to prevent it from happening the next time. I always recommend having heat tape with me if I have a no heating call with a furnace in an attic. Make sure you're getting your dispatcher or whoever it is that took the call should be getting this information for you. Is it a 90+% furnace? Is it in the attic? Is there a condensate pump? It's very easy things the homeowner can understand, but it's going to help you in the long run. Once you get that information, you know what to bring with you. Make sure you arm yourself. The next one is a bad blower motor. And I kind of touched on this earlier. The blower motor is the first line of kind of defense to debris, right? So you've got your filter. If it doesn't have a filter in it, or the filter is super, super dirty and hasn't been changed in a long time, that blower is going to literally suck all of that debris into the system. When that happens, we get a dirty blower motor. Whoop. Sorry, guys, I swapped slides for a second. So we get a dirty blower motor. When we get a dirty blower motor, it starts to corrode. It doesn't move as fast as it should. It adds weight and makes the motor overamp. There's lots of things that can happen from having a dirty blower. So every single time we're on a maintenance, we want to check that blower. And if it's dirty, don't even think twice. Just pull it out. You're going to be much happier that you took the extra time to pull this blower motor out and clean it than you are if you got a call back the next day for an overamping fan or for bad airflow. This is your most important part. It's always airflow before charge in AC. And whether you have a coil on top or you don't, airflow still comes first. It doesn't matter if it's AC or heating, airflow always comes first. So filters and coils, I say. The coils obviously are if it has an AC coil on it or if it's a heat pump. In this situation, we're talking about furnaces only, but I wanted to add that in there because sometimes you'll come up to a furnace and it has, an A coil sitting on top. That is still important. You still need to clean it if it's dirty. And then the secondary heat exchanger. So I will at the end go back to our dissection of the furnace to show you where the secondary is. This is so common because people don't know it's there. There are so many technicians out there that have never seen the inside of a furnace other than what they've seen on site. They don't get this lovely diagram that I've made for you all. And because of that, they don't know that there's a secondary heat exchanger up there, which is actually going to be above your actual blower. So you have a secondary heat exchanger that's kind of hard to see. The problem with that is that it gets absolutely filthy and we don't typically clean it because either we don't know it's there or we just don't check it and we're just busy cleaning the primary heat exchanger. Always need to make sure you look out for that secondary heat exchanger because it will put you with no heat. The next is a bad fan cap or relay. Whatever is controlling your fan in your furnace is prone to go bad. And that's because, again, when we get a dirty blower, when we get an old blower, when we get any reason for overamping or for, pulling too much amperage is what overamping means. So when our fan is working too hard, basically, that is wear and tear on your capacitor if it has a capacitor or your relay if it's powered by a fan relay. So you want to make sure you're checking those if you have a no heat situation. If your fans don't come on, check this first. Always check your power to your fan first and find out why. Sometimes it's really easy to do to just change out a relay or change out a fan cap. So next, we have flame rectification. This is super important. We have components within the furnace that make a sequence of operations of their own. So when it comes to the burner side of that, we're going to have either a flame sensor or we're going to have a thermocouple. So whether it is going to heat up and the heat is going to cause the flame, or it's going to be a spark that causes the flame, it doesn't matter. The same situation will happen with both. Whatever it is that gives you your ignition is going to go bad eventually. And when we see that, we typically see signs like the gas valve is feeding, but it won't rectify the flame. And when it doesn't rectify the flame, we can't keep pushing gas into the unit. So that flame, that gas valve is going to shut off. It's going to try and fail, try and fail, try and fail. So when you see that happening, you know that you don't have flame rectification. You know that your gas valve isn't going to continuously send gas and fill up the unit to make a big kaboom if we do get flame. It's going to try a few times and then it's going to stop trying. When that happens, you need to check whatever it is that gives you your ignition. And pressure switches can cut that. We have pressure switches in almost every type of unit. We have safeties of some sort, and it might not necessarily be pressure switches. In a furnace, we have a pressure switch with a tube. That tube is so prone to getting gunked up with debris and rust and whatever it is that the heat exchanger is, has inside of it. So if that little hole that pressure switch hooks onto gets clogged, it will act like either a bad pressure switch or it will act like it has bad pressure. Not necessarily the case. I always say, pull off your tube to your pressure switch, blow in it. If it opens, then you know that the problem is probably not the pressure switch. It's probably whatever is behind the pressure switch. I take a little tiny Allen key and I keep it on me for heating system. And I stick that little Allen key inside the hole of the heat exchanger from the pressure switch, and it will kind of remove at least enough of it to get the pressure switch to work. That's just a little tidbit from me to you. Excuse me, guys. This, I want you guys to all stop and take a picture of. Furnace maintenance checklist. If your company does not provide a furnace maintenance checklist, I would take this one, but I would also, after you've done a few of them, add to it on your own. This is very basic. This is the one that I start every one of my students and every one of my employees out with. The reason that we have checklists is not to say my employees are dumb, they don't know what the next thing to do is. This is to say, I don't want that to be your responsibility. I want you to have something tangible in your hand that says, I did my job. So if we do have a call back the next day, I can go through your list, see what you did. And then I can say, okay, this is why that was missed on maintenance. Or I can say it happened after the maintenance for sure. Make sure, you guys, that you're keeping a furnace maintenance checklist on you, even if your company doesn't require it, because this is going to save your behind in the long run. So first, we want to check and change the air filters. This is number one most important thing. You guys have all seen a dirty air filter in your lifetime. It is such a simple task that our customers will not usually tell us the truth about and will not usually do. We need to make sure we're doing that. We cannot go any further with dirty air filters in troubleshooting. We just can't. There's no situation where we're going to get correct numbers and correct measurements out of our system with dirty air filters. So make sure you change those first. Next is going to be check the thermostat operation. Make sure that if you're testing it for heating, that you're in heat on your thermostat. Make sure that if you're testing in cooling, that you're in cooling on your thermostat. And then as long as everything's working on your thermostat, you move to the next. Run the furnace in heating mode and record temperature readings from both the return ducts and the supply ducts to be sure that heating output is within manufacturer specifications. Every single unit you guys pull up to, you need to have a manual. If you don't have the manual physically on site, look it up. There are great resources for that. Make sure that you have the manual. We always say RTFM, read the fabulous manual. You can put whatever word there you want. But we need to make sure that we're reading the manual, because that's going to give us our manufacturer specifications for things like airflow, amperage, gas, everything. It's going to give us all the information we need. So when you're measuring the temperatures in your return and your supply, I like to use probes for that. You guys can use any form of, thermistor or thermostat or thermometer that you want to use. I use probes because they're magnetic and they, sit right inside my duct. You can use whatever you want for that as long as it's accurate. You want to make sure you're getting a good read on what your temperatures are, because whatever your return is going to tell you if something's wrong with the return side, and whatever your supply is going to tell you if something's wrong with your supply side. And then in the combustion chamber, this is, most people skip everything before this step and go right to this. And I'm here to tell you that that is wrong. Because again, you're not going to get an accurate read on what's wrong with your system with all the other things going haywire. So you need to make sure that this is not your first step. In the combustion chamber, check and clean the burner orifices and venturis. So we have an orifice that either converted from natural gas to propane the other way around, or we have one that came with the system because the system didn't need conversion. The orifices on all of the Venturis need to be cleaned. If they have rust in them, if they have dirt and dust in them, if they have, corrosion, you need to stick, again, a little Allen key inside those Venturi holes and clean them out. We have a crossover, we have an igniter. We talked about that already. Make sure that if you have a flame sensor, make sure it's clean, because a lot of the time we get misdiagnosed flame sensors that aren't actually bad. They were just dirty. And if it's say a warranty situation, you're going to want to make sure that igniter was actually bad before you diagnose it as such. And the only way to really do that is to clean it first. So always clean your igniter, whether you think it needs it or not. I just take a $1 bill. You can use, a little piece of light grain sandpaper, and you just clean the flame rod with that. Then you're going to want to check and adjust the gas valve. And we're going to get deeper into this as we go. So I'm kind of going to skip over that one, but I don't want you to think it's not important, because it is. And then in older furnaces, evaluate, clean, and tune the pilot light system. Some furnaces, and you guys won't see a lot of these, but depending where you are in the country, they still exist. I'm in Maine. I have them here still all the time, especially for oil. But what we have is standing pilot systems. So we see those in other appliances, right? You guys are doing appliances a lot of the time. We see those in other appliances, but we don't typically see them in furnaces anymore. However, when you do see one, you will notice that there is a flame in the burner all the time. And the reason for that, we will get into in a future class, but it's a standing pilot. It doesn't have a igniter system. It has the burner and the standing pilot flame instead. Make sure you clean that if you do come across one. And then inspect and clean the blower and blower motor. We talked about that in depth. Check for burned wires or high temperature problems. You guys, when you open up a compartment, an electrical compartment in a furnace, your best tool is your eyes. That's your first thing that you want to do, is visually inspect everything. So if you are visually inspecting the electrical compartment and you notice that maybe there's no wires physically melted or burned, but it has maybe a smell of cooking, like a burning smell, that will linger inside that cabinet. And that's a really good indicator that you've had a high heat situation. Another way to tell is charring. Maybe right now it's not hot in there when the furnace is running, but maybe it was. And so you see signs of charring on, maybe like the schematic is, in the electrical compartment, and you see some browning on the top of it that doesn't look like it's supposed to be there. Things like that. Just make sure that you're using your eyes to look for high heat and melting situations, because those are going to be your number one callback. If you go to a maintenance and you don't check every single wire for melting, it's like Murphy's Law out here, that the next day somebody will call and, they have a chewed or a melted wire as the problem, as the culprit. Cover yourself, because you don't want that call back. It's embarrassing. I've had it on myself many times. It's when we rush or when we forget a step, and this is why we do checklists. When we rush or forget a step, it's always that step we skipped that brings us back. I had for example, I had a evaporator inside a walk-in, and I didn't bring my checklist with me. I was very, very new to the trade. And I walked in and I did my maintenance, and I was so proud of that maintenance. This thing was sparkling clean. You could have eaten off it. Everything was beautiful. Motor amps were great, whole 9 yards. And the next day I got a call back because I didn't amp the fans. And one of my fans was over amping. After I cleaned it, it wasn't working as hard, and the fan went junk the day after I was there for maintenance. Don't let things like that happen, you guys. Remember your checklist. Learn from my mistakes. Then we have clean the heat exchanger and check for cracks and holes. I skipped over this one on accident. Sorry, you guys. This is the most important one. This is where we save lives. When you come up to a furnace and you don't want to clean the heat exchanger, so you're like, oh, it was just done last year, I'll just skip over that part. No. A crack or a hole can appear seemingly overnight. This is how it happens. It just cracks one day. When we have a cracked heat exchanger, not only do we have poor combustion and we have dangerous combustion, but we also have dangerous levels of carbon monoxide and other particulates, other chemicals that are made by, so when we make a chemical, it's just two separate things mixing together, creating a hazardous chemical. This happens within your heat exchanger. So when you have a crack and those chemicals are seeping out, it's not just CO we have to worry about, but CO is deadly. And it is, again, the silent killer. If they don't have good CO detectors, if they're not placed in a place where it can read it, these people really could lose their lives or get very, very sick because we missed a crack or a hole in the heat exchanger. We can't let that happen. If you do nothing else on this list, inspect the heat exchanger, period. And then at the bottom, we have inspect the flue pipe and ductwork. There is really no good way to do this. Obviously, we're going to talk about static pressure readings and testing the ductwork that way. However, the flue pipe and the ductwork are sealed systems, right? So what we want to look for is signs that they need to be inspected. So if you have poor ignition in your furnace and you can't find any other reason why, very, very possible that there's a critter or a bird's nest or, snow or ice within your flue pipe. Very good indicator. If you have something like that that's happening, make sure that you check your flue. I have seen many, many times animals causing this. Oh, let me get back to the page we're on. Okay. This is why I skipped over the gas valve. We're going to talk about the gas valve a lot. And you guys, please, I know I'm going kind of fast through this. Please put your questions in the comments because I did leave time at the end to go over and answer them. No question is a bad question. Okay. There are only bad answers. No bad questions. Make sure you put them in the comments. So what makes a flame bad? So I really wanted to show you guys on my training system, but it is far too warm still to fire it up in heating mode and actually stand here and teach next to it. So we're going to go ahead and do it this way. Proper gas flame appearance. A lot of people are not trained in this, and this is why I always bring it up. When we have a natural gas system, our flame should be 100% blue like this. We should have the lighter flame right where it comes out of the burner, and then at the tippy top, we should still have blue. That is the perfect natural gas flame. We don't want to see licks of yellow floating out of that. In a propane system, you're going to have a little bit of yellow at the tip. It's not going to flick or roll out, though. If you have a proper liquid propane flame, you're only going to see that little bit of yellow at the end where the flame starts to die out. And that's completely normal. What's not normal is any more yellow than that. As you can see on this side, we don't have two bad flames, one for natural gas and one for liquid propane. We have any orange that is above and beyond what you see in these two pictures is bad and needs attention. Flames should not be orange when it comes to a heating system. They should always be blue. They should be coming out fast. If you have flame rollout happening, which I will show you guys, if you have a little bit of, yellow flame rolling back over the burner, there's something seriously wrong. And that could be a good indicator that the heat exchanger is bad. Not that that's the only reason. We're going to go over that, but it is a reason, and it is a very dangerous reason. So outlet gas pressure is one reason. If we're not getting the proper outlet gas pressure out of the gas valve, we could have a really nasty yellow flame and flame rollout because we're not getting the proper amount of fuel to air ratio in order to burn. And then airflow across the heat exchangers or cracks heat exchanger. That's what we talked about. If you have a cracked heat exchanger, 9 times out of 10, you're going to have a nasty yellow flame. Poor combustion, that can happen for lots of reasons. We can go over this improper conversion one with this one a little bit. So again, if you have a natural gas system that is set up for natural gas from the factory and you do not convert it to liquid propane when that is the gas in use at the home, you're going to end up with poor combustion. You will have a nastier heat exchanger in half the time. Your heat exchanger will be more prone to cracking and getting holes. You will have really yucky flames, and you will have a soot problem. Soot is the number one, byproduct of an improper conversion. You'll see soot kind of everywhere. Places it doesn't belong. You'll see it on the burners. You'll see it everywhere. And charring. When you see charred venturis in a burner system, look for the conversion and see if it was done properly, because a lot of the time that's the cause. And then when you have weak or improperly wired blower, again, the blower is our first line of defense. It's the thing that keeps the airflow going throughout the house. It's what keeps the return coming back. It's what does all of the air movement that we have within this furnace and within our homes. When it's not wired properly, if it's, set on low and it needs to be on high or vice versa, we're going to have improper airflow. When we have improper airflow, we will have improper flames. So moving on, how do we test gas pressure? How do we know if the gas pressure is right? So first we need to know why we need to know that. Why does it matter? Too low of a pressure can result in incomplete combustion. This causes your furnace to run inefficiently and potentially release harmful byproducts like carbon monoxide. That's what we were talking about earlier. On the other hand, excessive pressure can put unnecessary strain on your furnace, leading to premature wear and potential safety hazards. I have seen furnaces go boom because the external pressure, the outlet pressure was incorrect, and so was the inlet pressure on that one. So when do we need to remove a gas valve? First, we need to test it and make sure it doesn't need to be removed. So first, we're going to shut off the gas on the line. You guys know what a gas shutoff looks like. Always make sure you find them all. Some systems have more than one gas shutoff, and you need to make sure that they're all off. Remove the inlet and outlet test ports on the gas valve. So you see Allen keys. We have kind of like a little screw on one side, which is the inlet, and a screw on the other side, which is the outlet. You guys will know the difference. There are arrows on the gas valve, but you will know the difference because you know where incoming fuel is coming from and where outgoing fuel is going. You're going to install your manometer brass screw fittings into the gas valve test ports. And I will show you guys, I think my manometer is down here. I will show you guys what this looks like. If you don't have a manometer and you're going to be doing gas heating, you need to make sure that you get one. This is probably the most important thing you can get. It doesn't just measure gas, it measures pressures, right? So we can measure our static pressure with a manometer. We can do all kinds of things with this tool. So make sure you get one and you get a good one. And if your boss doesn't provide one, you can actually put in to request one because this is one of those tools that are typically provided by the company. And then we're going to install the manometer brass screw fittings into the gas valve test ports. So we're going to take out the screws and we're going to put in our fittings, which on one end is hooked to a tube. On the other end is hooked to a tube. We're going to put one in each. Then we're going to zero out the manometer. You want to make sure it's reading 0 because otherwise you're going to test, ambient pressure, all these kinds of things that you don't want to test. You're going to make sure you're zeroed to atmospheric pressure. If you guys, one time I tried to test the system and I was zeroed out, but I was zeroed out in absolute pressure. Absolute pressure is not what we are currently in when we are just walking around the world. That is what it's like on top of the mountain or bottom of the ocean. These are absolute pressures that we don't ever see. We need to make sure that we are absolutely in atmospheric pressure, which is 14.333, whatever. But it won't show you the number. It will just zero out. Make sure that your button is clicked to atmospheric. Open the gas shutoff at this point. So again, we don't want the gas on until we are completely hooked up with our manometer and ready to go. Make sure you turn the gas off in the beginning, turn it on after your manometer is zeroed. And if you follow this step by step, you guys take a picture. This is so helpful. This is from HVAC school and they allow us to use all of their materials. This is a great resource. Make sure you take a picture of this. Then you're going to go to the thermostat. You want to run the appliance in heat mode. You want to make sure you have a call. So I have had calls to my tech support line where people hooked up their manometer and they put it in heat mode and they're like, why isn't it working? I don't have a call. That's because they forgot to turn up the thermostat. Very simple mistake. We've all done it, but make sure you turn your thermostat up so that you're always calling while you're doing this. So confirm that the inlet pressure maintains above the minimum inlet pressure with all the gas appliances running. So this is important, you guys. If you have a gas stove, a gas furnace, and a gas fireplace, and they're all on the same line, you need all of the shutoffs closed when you start out, and you need all of them open when you're running, because we need to make sure not only is there enough inlet pressure to our furnace, but we need to make sure that there's enough inlet pressure to run them all at the same time, if need be. So that's how you test your inlet. You're going to look in the manual, you guys. Your proper measurements are going to be in your manual. However, we can get close to that either way. For natural gas, you're always going to want to be between 3.2 and 3.8 inches of water column. And then for propane, you're going to be within 10.5 to 11.5. You can go 12. I typically look for a 12, 10 to 12. But just make sure that you're not super much above 11.5 inches of water column for propane. And then you're just going to follow the manufacturer specified pressure. So if it's different for what you're working on, it might not be a furnace. If it's different from what you're working on, then you need to know that RTFM, read the fabulous manual. And then you're going to turn the adjustment screw clockwise to increase the outlet pressure if it's wrong. So if your outlet pressure is not within those parameters, you're going to just turn the screw to open that up a little more or to close it off a little more. So if you're working on something that's natural gas and you're getting 5 inches of water column out the outlet, you're just going to damp that screw back a little bit until you're reading the proper discharge. And then again, on the other side, if you don't have enough, just turn it the other way. And then once you're adjusted to match design input, shut off the gas, remove the brass screw fittings, and reinsert the plugs, the screws. Then you're all done. Make sure that you document your measurements. So if you're going to take amperages of your fan motors, if you're going to take gas valve readings, make sure you're documenting those, because those will help you the next time you're there for, say, troubleshooting. You can say, okay, 2 weeks ago, this is what I was at. Now the gas is not working again. I must have an intermittently failing gas valve. These will all be little tiny tools that can help you in the future. And again, you guys, make sure you go back and screenshot this if you haven't yet. Next, we have static pressure. And I know this is a lot of just me talking, you guys. Again, please put your questions in the comments so that we can have a conversation about this after. I'm not trying to fly through it. We just only have an hour, and normally this would take a lot longer. So static pressure. Again, we have this awesome graphic from HVAC school. Take your screenshots, you guys. These are just tiny little things you can do that'll help you out in the long run. Static pressure is important. Why is it important? It's an important factor in HVAC systems because it affects the flow of air through the ducts and vents. If the static pressure is too high, it can restrict the flow of air, leading to poor air distribution and reduced efficiency. On the other hand, if the static pressure is too low, it can cause the air to leak out of the ducts and the vents, reducing the effectiveness of your system. So at this point in our lives as adults, we've seen a lot of situations where something moving too slowly causes it to leak, right? So you've seen, picture a hose. If you have a hose that has a tiny pinhole in it, when you have the pressure on your hose of your water super, super high, it may not leak out of that hole. But when you turn the pressure down, it's going to find ways to remove itself from the hose. And that little pinhole is a perfect escape. This happens with your air ducts as well. So if we don't have properly sealed air ducts, if we don't have the proper register sizes, and if we don't have the proper static pressure, we're not going to be able to keep all of that air within our ducts. So how do we change it? I'm just going to go over this quickly with you guys. Verify that the system and air filter is clean. So make sure that all of your cleaning that you're going to do and your changing of your your air filter is done before you try to run this test. After that, you're going to run system in cool or heat, whichever one has higher airflow on that system. And then you're going to zero your dual port manometer, same tool we use for the gas valve, guys. You're going to zero that into the return and supply, and put one into the supply and one into the return. This is where you want them, above and below the furnace or fan coil. And then you'll have 2 single port Bluetooth manometers mapped for positive and negative pressure, respectively, would work as well. So those are the probes we're talking about. In this picture, we actually have a probe. So you're going to locate in the center of a straight duct away from any turns or turbulent areas. So you don't want a corner. You don't want to do this on a 90. You don't want to do this on a place where the air is reduced. You want to do this on a straight, beautiful duct run. And then you're going to insert your port into a little hole. We just use a drill to drill the hole and put it in there. Some of them already have them if it's an existing system. Then you're going to locate in the center of a straight duct run away from any turns or turbulent areas. Whoop. Sorry, guys. Go back. For your other probe, you're going to put that one before the unit and after the filter. And then the holes in the side of the probe should be perpendicular to the duct walls. You do not want these holes placed in the wrong spot. Make sure you take a picture of this, you guys, because then you'll know how to drill your holes. Probe tip should be positioned in parallel with the airstream. So if it's upstream or downstream, it doesn't matter, but your probe needs to be parallel to it. The difference between positive and negative pressures. Measure total external static pressure. So you're going to get your negative and you're going to get your positive out of your manometer, and then the difference is your external static pressure. High return static may be a dirty filter or undersized duct. That can also be a blower motor that's running too slowly or too fast. It can be all kinds of reasons. So if you have high return static, you need to check into the reason. And then high supply static may mean supply ductwork is restricted or undersized. So if you have high static, that means high restriction. So something is restricting that duct from working properly. Make sure that you pay attention to the individual supply and return static pressure. So Don't just put it together for your total static pressure. Pay attention to each individual. And then make appropriate adjustments. A lot of this is common sense, visual inspection, knowing what causes high or low static pressure, and then going and adjusting those things throughout the system. Make sure you guys take a picture of this. It's super helpful. And now we are at the end of the presentation, which I am super happy about, and I am happy to answer any questions you guys have. If you do have questions and I don't get to them in the next 5 minutes, that is okay. You guys can always find me at Jennifer@skillcatapp.com. I'm going to go ahead and post that in the comments so you guys have my email. So things to think about when we have a coil on top of our furnace. We still need to be checking that out. I'm actually going to show you guys here one of my little handy dandy AC Service Tech posters. So when you have this going on, so this shows the coil below, sometimes it's above, doesn't matter. This is what happens when we have a dual fuel system. So we have this is just an air handler, obviously in the picture, but we can have this on top of a furnace. So when we have a coil on top of the furnace, we still, even though we're not in AC mode, especially if it's a heat pump, we want to make sure that we are cleaning that coil. So regardless of, we're in heating and it's dual fuel, I'm using gas, I don't need to worry about my coil. But on the off chance that they need AC for any reason, and when we first get into AC season before AC maintenance, they're going to turn on their system and they're going to have a dirty coil. You're going to get a no AC call super early in the year. You want to make sure that you're cleaning that on maintenance. A system is a system, you guys. We don't separate the cooling and the heating of that system. Other things to note. I guess my biggest thing is I want to reiterate that we are talking about gas systems. Not all of you will see those, because if you don't have a gas license, you're not supposed to work on them unless you have a gas helper's license and you're working under a superior with a gas license. However, you guys are in apartment maintenance, you're in, appliance repair, and we see a lot of gas systems. So I want to make sure that you guys know what you're looking at, because to run a maintenance, as long as you're not checking the gas valve and you have somebody, who is licensed checking your gas valve, you can still run the other stuff on the maintenance. So I want to make sure you guys are doing that correctly. The biggest thing I wanted to push today was the importance of checklists. Nobody expects you guys have to learn so much about so many different systems, and nobody expects that information to just live rent-free in your head forever. You guys have to constantly switch between, and I don't envy you guys having to constantly switch between systems. There are a lot of you here who will show up and have to do, a gas stove, and then your next call of the day is literally a Whirlpool tub. You guys have so many different things on your plates. I would never want you to think you have to store that information. Because of that, we use checklists. What I did, and this is a tip and a trick that I give to all of my students, what I did was made a portfolio of checklists. So I now have probably, 50 to 100 checklists, all different systems, all in one portfolio. So make sure that you guys are helping yourselves out. Helping yourself is the best advice I can give. So helping yourselves some other ways. So get your portfolio book of checklists. That will be your best friend. And I promise you, all of your little tech friends, all of your coworkers are going to envy you. They're going to want that checklist book, because you never have to remember anything. You show up at a job and you open it up to that page and you know exactly what to do to maintain that system. And you can even do a troubleshooting section. I've done troubleshooting sections that I use for training for my coalition. We can compile a list of the things we've seen before, and then we can put that list in the back of this maintenance checkbook. If we get to a system and we're there for maintenance, but we find something wrong and we're not sure how to start, you have that troubleshooting checklist right in the back of that portfolio. You're going to help yourself so much more by doing these little tiny things than you won't do yourself any justice standing on a roof or, in a client's home or in the basement trying to figure out where to start for an hour, because you're not sure, okay, I don't even know what my symptoms are. This thing won't even turn on. Where do I start? You guys have that in your checklist. Make sure that you're compiling all the information that you come up with throughout your career and put it in a binder of some sort. You can even do it on a computer or, in your notes app. You can do voice recordings. I have a buddy who does voice recordings of everything so that he can play it back to himself. And then utilize YouTube, you guys. If you don't remember something and you forgot to take a picture of it or you forgot to document it, go to YouTube. I guarantee you if you've seen it, somebody else has seen it. And we live in a world where that information is at our fingertips. So utilize it. Even super seasoned techs, I still use YouTube every single day of my life when I'm on site. Make sure you're utilizing that. And again, RTFM. What I always recommend, and this is going to seem tedious and it's going to seem like, one of those girl attention to detail things, but it will help all of you. And I pass this on to all of my techs, no matter what gender they are. Take pictures of the manual. So we show up at a unit and on the off chance, the beautiful, magical off chance that the unit is actually equipped with a manual, we want to take that manual out and not only read it, and I mean front to back. The service manual, you should be reading front to back before you ever touch a system to troubleshoot it. We want to read it, and as we're reading it, we want to snap pictures of every page. You can then take that manual and put it in, say, a separate folder so that it's not like in your pictures. You can make a separate folder that's just for manuals, and you can put all those pictures together, especially if you have an iPhone. You can put all those pictures together and you can label it, train, and then the model number, whatever it is that you saw that day. When you do that, you will eventually, and I promise you, you will eventually see the same thing twice. When you see the same thing twice, the next one isn't going to have a manual. That I can promise you. So you will have that in your, book of defenses, so to speak. That will help you in the future. It may not seem important at the time, important enough to, take a few pictures, but what are those 5 seconds going to save you in the future? That's what you need to be thinking about. Take pictures of every manual you come across, you guys. I promise you, you will thank me someday. That's pretty much all I have for furnace maintenance specifically. Remember the key takeaways from this presentation. Remember to never touch a gas system unless you're in the presence of a licensed technician. Don't read the manual. Always, always, always read the manual. Always bring a checklist with you. And then on top of that, always inspect the heat exchanger. If you don't remember to do anything else on my checklist, you guys, inspect the heat exchanger because we are out here saving lives. I can't tell you how many people I have had to condemn their system because I knew that when I walked away and they went to bed that night, they may not wake up the next day. That's your job. It's your responsibility. Make sure you're not skipping over the heat exchanger. Yes, it's the hardest part to clean on the whole furnace. It's a pain in the ass. You can't get in there. It sucks. But we're saving lives out here. So make sure that you inspect that heat exchanger. All right, you guys. I'm not sure if anybody is here live. If not, do you guys enjoy this recording? If anybody has questions for me, there is my email in the in the comments, but I will say it again in case it doesn't show up. My email is jennifer@skillcatapp.com. I am happy to answer any questions you might have. And again, for all of your parts and supplies needs, go to encompass.com, you guys. Make sure you get their inventory app. This is an amazing company. They're offering you guys free training once a month with me on top of all the other awesome training opportunities they have. And then they have that app to make sure that you are never on site without the parts or equipment that you need, and you can get it right through them. So why wouldn't you, right? Always go to encompass.com for all of your parts needs. Thank you guys for joining me today. I will see you guys next time at the end of the month, and we will go over some more heating maintenance tips and tricks. Thanks.